All right, good afternoon, everyone. It's always nice to actually be on time, nevertheless a little early. My name is Jeff Janukiewicz, and I am the Research Director at IDC, where I manage our coverage around SSDs. I am actually one of the people who actually has been around this conference for a number of years. I think I was at the very first one, and it's completely amazing to me to see not only how big this conference has grown, but in concert with that, how big the industry has actually grown over that period as well. And really, from my perspective, one of the key things that's driving a lot of the growth in the overall market has really been centered around innovation. And I think we've heard that in a number of different keynotes and some of the other sessions that have been put forth here. But we've seen innovation around improving NAND, not only just from a performance perspective, but from a cost basis as well. We've also seen innovation around managing NAND. We've also seen a lot of innovation around enabling the ecosystem to take advantage of NAND. And it's actually my pleasure to introduce someone who's had a direct hand in a lot of that innovation, Mr. Derek Dicker. Derek Dicker is the Vice President of Performance Solutions for PMC Sierra. So if you would, please join me in welcoming Derek.
Thanks. Good afternoon. First off, I'd like to say that it's an absolute pleasure to be here in this room today with the crowd at the Flash Memory Summit. This group is responsible for fundamentally changing how a lot of us experience life. And yesterday we saw some great examples about the fact that flash memory is really one of the technologies that, when paired with apps, can do some very innovative things. We saw examples citing back to the use of Uber and the disruption to the entire transportation industry wrapped around it. We see with Amazon examples of shipping product to homes. It's fundamentally disruptive and life-changing. I think the one that was most interesting was the example of Tinder and how people are starting to actually get connected in very, very short periods of time. All of this is absolutely unique to how we work and live and play. The fundamental premise that I want to talk about today is not about how our lives are being changed as much as how this keynote's being changed, because I don't have a clicker. Oh, you stole it, Phil. Good luck with that. Even still. Thanks. So, we believe that non-volatile memory is changing everything. And this is happening uniquely from our perspective in storage architectures. And I wanted to kind of give a description of what that might look like. If you look here, this is a framework of kind of a very high-level view of how a storage system is comprised, with compute on the far left, obviously a bunch of different CPU options available there. Storage and control management as the next section where we have today RAID adapters and host bus adapters. There's expansion. So once you can control the storage, you essentially have a mechanism by which you want to be able to scale out to multiples of drives. And then lastly, on the far right, you have media. And in the days gone past, this was essentially SAS and SATA with rotating media. But what we noticed looking back in history was that there was this ripple effect that was created by non-volatile memory. And it started with solid-state drives being introduced into the infrastructure. Now what happened is you went from rotating media drives that function at hundreds of IOs per second to all of a sudden we had something that was functioning at thousands of IOs per second. And that created some really interesting effects as you go back into this chain and you look at what happened to expansion. Now from our perspective, we provide expanders into the storage systems and the servers today. And what we found very quickly was, hey, wait, if solid-state drives are going to show up, all of a sudden the expanders that we have are going to have this focus on very, very low latency. And also, it's going to create some level of back pressure onto the controllers, where there's going to need to be some level of buffering between these, because you'll have some drives that are functioning at a 6 gig rate and some at 12, and these controllers are going to have to be really, really highly performant, and they're going to have some connectivity to the expanders. So there was RAID stack tuning, there was driver tuning. And then lastly, the CPU vendors of the world came out and said, hey, we realize that all of these subsystems are growing at a very, very rapid pace in terms of their demand on our CPUs. We need to carry forward interconnects such as PCIe. So the whole story here is essentially starting from the far right with the introduction of new media. There was this big sea change that took place across all of the different subcomponents of a storage system. And what we saw over time is people said, all right, that's actually really interesting, but putting this fast media attached to a host bus adapter or array controller, kind of through the chain, that's good if we improve the performance of those, but what if, just what if we could actually take these things and we could push the drives into the PCIe space and connect them directly to the CPUs. And over time, what we saw was this kind of partitioning of two tiers. And Phil mentioned, tiered storage as an option. This is a very high rendition, but a high-level rendition. But essentially, what we saw happening was that PCIe became desired as the interconnect for the performance tier. And that started on the far right-hand side, as you see, similar to before, with the creation of PCIe SSDs. Now, there was a very early market and several people who got out early. And all of the solutions, they were proprietary in nature. But over time, what became the case was the creation of NVMe. So several folks, ourselves, along with Intel and Dell and many others, participated in creating industry standards around the protocol for how you talk to these drives. No longer was a proprietary driver required that exists today. We now have a standard driver. Connectors were defined to allow front panel slots to be built into servers and storage systems that allowed drives from multiple vendors to be interoperable in a given system. A series of these standards got created, and essentially all of a sudden you have the makeup of this environment where you've got this really fast SSD, this fast media connected to this fast interconnect PCIe, and you can start to build big systems. Now, before I go through the rest of the ripple effect that we see here, I want to take a quick dive into the PCIe SSD space. Last year, we kind of posited a theory that there was this phenomenon going on called software-defined flash. And we drew a parallel to software-defined storage, where you see a base platform in software-defined storage, an industry-standard server that's delivered to the market. And a lot of the differentiation of the management features, the storage management features, are done in software on top of that base platform. And we said, hey, isn't there an opportunity here to do something similar with flash and with SSDs? And so we coined this term software-defined flash and attempted to define it as an enterprise-class solution that has a base platform upon which firmware and software can be used to maximize the value of that media that's in the drive. And we also further took it another step and said, well, in order to do this, there needs to be an ecosystem. You have to have some key components. Now, a traditional system today, if you look at it, you have an SSD that sits underneath an operating system with applications running on top. And that SSD is built now with a series of different workload profiles to it. You can buy a read-intensive, you can buy a write-intensive, you can buy a mixed workload. But what if people controlled applications and they kind of knew that flash was down there? And what if you could actually create an SSD where there was a firmware stack that was aware of the application profile and the workload that existed? And you could select the right memory type for the given right workload and put together solutions that were tailored for the work that needed to be done. That was a vision behind software-defined flash that we described. Now this year, just to provide a brief update, from our side, we provide controllers into this particular space. And the first generation product, we branded it FlashTech, today has 40 unique SKUs being built on top of that base controller. This description of utilizing multiple types of NAND from multiple manufacturers has been realized. 5 out of the top 6, 5 of the only 6 NAND manufacturers have been used in these SSDs. There's also SLC-based drives created, MLC, eMLC, and now emerging TLC-based drives. We have different form factors. So there's add-in cards, you can see that here. There's 2.5-inch cards. The ones that are actually also intriguing are the custom form factors. We have customers that have built out of a single very, very narrow sled 8 terabyte drives utilizing our first generation controllers. And the innovation that's happening there is truly impressive, some of the things that we see people doing. Now, we're actually really happy that this isn't over yet. We're actually carrying the momentum forward with the announcement of a second generation product that we announced earlier this week, the FlashTech NVMe 2032. Now this device, actually we focused on taking the performance up a notch. What we announced was a 1 million IOPS capable controller. We have a demonstration of this in our booth. If you have a chance, please come check it out. We've also taken advantage of the fact that, several of us have heard over the course of the last day and a half how much capacity is coming with the advent of 3D technology. And so we've built support for large capacity into these controllers. We've taken out of our heritage in the telecommunications space the concept of LDPC, ECC, and embedded an adaptive implementation into our devices. And what that allows us to do is to take advantage of all of the next generation NAND nodes that are coming around 3D. And finally, in the spirit of trying to create some level of optimization around software-defined flash, we've built engines that sit on the flash channels that allow for a very flexible means by which you can talk to the media. So for those vendors who have special commands that they want to see exercised, for unique tricks that want to be played, how you talk and deal with the media, we've created this programmable interface, and we support the latest toggle and Amphi generations. So in summary, we feel really good about the momentum behind SDF, the momentum behind this use case, and how people are actually building next generation SSDs. So let's go back. We pop back to this whole notion of two different tiers, the capacity tier and the performance tier. Now remember that what I mentioned was we saw this ripple effect going from the media being installed inside a solution, and this ripple effect of changes required going from the far right to the far left in that diagram from media all the way back to the compute. One of the challenges that we've seen and experienced as we've worked with the industry to build PCIe SSDs is the fact that there's no clean, easy way to aggregate multiples of these into one place the way you would with an existing storage enclosure, like a SAS-based enclosure. And so then the question becomes, all right, what's the ripple effect from PCIe SSDs back into the expansion section of the performance tier? And for us, we actually we see some limitations with today's PCIe switches that are out there. Well, the first one is that they're not inherently designed for scalability. If you look at the switches that are designed today, they're essentially set up for a fan-out model, which makes total sense given the usage of PCIe in the past, taking multiple endpoints and then aggregating them together with a switch to connect back into a root complex somewhere in the system. The second is robustness and resiliency. Now, one of the things that, as we've talked to people about the implementation of software-defined flash and building solid-state drives utilizing our controller technology, what people have talked about is, hey, I want to be able to manage these drives in an enclosure, and I want it to look like SAS. I want it to feel like SAS. I want to be able to hot plug it. I want to surprise plug it, unplug it. I don't want blue screens. Thank you very much. What they really wanted was to try and take some of the learnings from SAS and apply it to PCIe. And that's being done, but it's being done with a fairly large amount of effort being placed into the system and being hacked together. And the last piece is people have cited the desire to actually have some degree of programmability on these switches themselves. And actually, I take that back. That's not the last thing. I think the last thing is people want choice. The industry has been served by just one individual for a very long period of time, and we see a great opportunity for us to help add to the ecosystem for PCIe switches. And so, essentially what we've done is eliminated the lack of choice, and we've introduced a family of products. Now, this family of products are our storage switches, and you can see 5 images of devices. We offer a 96 lane, we'll offer an 80 lane, 64, you can read the rest, 48 and 32. But it's a full family of PCIe switches, storage switches. And if you look at just a use case, all right, so what can somebody reasonably do with these switches? We took a pretty highly dense 40 drive example of an all SSD array, and we built it out with kind of the existing technology that's out there today. And essentially what's required to get to 40 by 2s bolted into one of these SSD arrays and being able to deliver some level of a user experience is 3 switches, 296 is a 48, and then an external baseband management controller of some sort. Now, with a PSX product, a 96-lane product in the exact same use case, what we've been able to do is take the power of that overall solution and drive it down. We've been able to take the device count and drive it down, which obviously helps with board real estate. And then lastly, we've given this ability to add value through firmware on top of the device itself. So we've been really excited about the customer reaction that's come back given the amount of features that we put into this device, specifically around resiliency. I mentioned error containment and the concept of surprise plug and hot plug. This is integrated into the device. We put a series of diagnostic and debug capabilities into the device to allow customers, when they're designing this in, to work through some of the biggest challenges that they've historically had integrating these switches around signal integrity and the like. We've also taken port bifurcation, where these are typically devices that cut down to 18 lanes per port, or even 8 or 4 lanes per port, and we've actually given the capability to bifurcate down to 2 lanes per port. And we put this on a 28 nanometer process. And lastly, we also have a very high port count delivered and NTB density behind it, non-transparent bridging density behind it. The last piece, which I alluded to, is this notion of a programmable switch, where we have the ability to actually add features, and our customers can add features on top of these devices. Now, this is one of those cases where we took the best of what PMC knew in the storage space and married it up with the best of what the team brought to us in the PCIe switch space and married these together. And what I mean by that is with our expanders, the SAS expanders that play very well in the capacity tier, we've developed an SDK. And our customers actually take that SDK and they develop all of their own special features on top of that. How they handle management, how they blink LEDs, how they manage through errors. And they've invested. They've invested substantial amounts of firmware time and effort into making sure that enclosure of service works the way they want it to. What we've done is we've taken that same SDK and all of those interfaces, and we've taken it from the SAS world and we put it into the PCIe world, where the goal is for those who've invested on top of our SAS expander products to leverage all of that firmware work into our PCIe space. And so we've taken literally the same enclosure management processor and we placed that into our SwitchTech switches. Now, all of this, we can't help but say, hey, we saw this trend of software-defined flash. It's almost the exact same thing happening in switching. People now have the opportunity to do some very interesting things on top of a PCIe switch that historically, if you have a hardwired platform, you really don't have the ability to add any differentiation to. Now, what could some of those things be? We see interest in drive partitioning off the switch, the ability to take a set of PCIe SSDs that are setting off of that switch and assign them to a particular host and then move them around. The idea of sharing resources across a PCIe infrastructure, or even in some cases, customers with whom we've engaged on this particular product said, hey, we want to build a fabric of PCIe. That's a big, big task, but at the same time, it's only going to be done if you have some level of programmable infrastructure behind it. So, if you look at the summary of all of this, what we see in the PCIe space is not unlike what we saw in the SAS and SATA space. The performance tier is going through the exact same ripple effect that occurred in the capacity world not too long ago. And it's actually happening at a much more accelerated pace. Today, we're actually proud to showcase in our booth the FlashTech controllers that we just introduced this week, as well as the SwitchTech controllers, SwitchTech switches, storage switches, down in our booth. So I would invite you, if you have the opportunity, please come join us, check out our booth, ask some questions. All of our silicon is down there, interoperating, and I know the team would love to connect with you. So thank you very much for your time. Have a great show.